good morning students. I am Vaishakhi Shah from LJ Institute of Engineering and Technology. In our subject called Fluid Mechanics and Hydraulics, we studied the chapter Open Channel Flow, and in last lecture we derived some derivation for most economical rectangular as well as trapezoidal section. Okay. Now in this session we will solve some examples based on most economical trapezoidal and rectangular section. Clear? So now we will start our example. So let's. A rectangular channel carries of water at a rate of 400 liter per second when bed slope is in 1 in 2000. Now find out most economical dimension of the channel if C equals to 50. This data is given. Okay. So first of all, most economical rectangular section. Here section is your rectangular section. The discharge is given, which is 400 liter per second. Now we are converting 400 liter per second into meter cube per second. So you get Q equals to 0.4 meter cube per second. Now B, that is your width of the channel, and D is your depth of the channel, and I, that is slope. I equals to 1 upon 2000. This is given. C is your Chase's constant, and here C is a 50. C equals to 50. Now we have to find out B and D, width and depth. Here B and D are the unknowns. Okay. So let's start. First of all, for most economical rectangular section, what is the condition for most economical rectangular section? Yes, D equals to 2D, and second condition M equals to D by 2. Now B, that is width, D, that is depth, and M, that is hydraulic mean depth. Okay. Now if we have to find out area, then what is the area for rectangular channel? B into D. So B into D equals to 2D square. Okay. So discharge Q equals to, as we know the equation for discharge Q equals to C into A under root MI. Now we have values of discharge, which is 0.4. Now C we have 50, area that is 2D square under root M. Now what is M? D by 2 into 1 upon 2000. So you get D equals to 0.577 meter, and B equals to 2 times into D. So B equals to 1.154 meter. So your final answer for B and D are D, that is 0.577 meter, and B, that is 1.154 meter. These are the width and depth for most economical rectangular sections. Okay. Find the velocity of flow and rate of flow of water through a rectangular channel of 6 meter wide and 3 meter deep when it is running full. The channel is having bed slope as 1 meter in 2000. Take Chase's constant C equals to 55. These values are given in your data. First of all, we have to find out velocity of flow, and also we have to find out rate of flow, which is discharge. So in this example you have to find out discharge and velocity. Okay. But for what? A rectangular channel, and width of this channel is 6 meter. So here, as you can see, this is your rectangular channel where B is your width and D is your depth. So width of this channel is given to you, which is 6 meter, and depth of this channel given to you 3 meter. Okay. So here B is 6 meter and D, that is 3 meter. Okay. And a slope, bed slope is given 1 meter into 2000. So 1 divided by 2000, 1 gem 2000, that is value of I. Bed slope is indicated as I, okay, and here Chase's constant given, which is 55. We indicate Chase's constant as C, so C equals to 55 is given, and we have to find out velocity and discharge here, okay. So velocity indicate as V and discharge we indicate as Q. So we have to find out V and Q here, okay. So now for most economical rectangular section, the condition we derived in our theory was first B equals to 2D. The first condition for most economical rectangular section, that is B equals to 2D, and the second was M equals to D by 2. M equals to D by 2, okay. So now if we have to find out area of flow, then what is equation for area? A equals to B into D. So you can write down A equals to 2D square, okay. Now discharge Q equals to C into A under root Mi. We know the equation, we use this equation from Chase's formula. Q equals to C into A under root M into I. So we have the values of Q here. Q, that is 0.4 into 50 into 2D square into M, M that is hydraulic mean depth, and M equals to D by 2 into 1 upon 2000. So D equals to 0.577 meter. Now we have to find out B, then B equals to 2 times into D. So your answer for B is 1.154 meter. Clear? We are taking Q, that is 0.4 from our earlier example. Here in this data Q is given, that is 400 liter per second, which we converted in meter cube per second. So Q is 0.4 meter cube per second, okay. So now moving for our next example, a trapezoidal channel of side slope 1 horizontal to 2 vertical and slope of bed is 1 in 1500. The area of the section is 40 meters square. Find the dimensions of this section if it is most economical. Determine the discharge of most economical section if C equals to 50. In this data, first of all, trapezoidal section is given. In this trapezoidal section, we have to find out dimensions. So dimension are width and depth. Dimensions for trapezoidal channel are width, that is B, and depth, that is D. So you have to find out B and D here, okay. For that, the area given to you, that is 40 meter square. So which is your capital A, area that is 40 meter square. Now C is Chase's constant and C equals to 50. C equals to 50. Now here two slopes are given. First is side slope and second is bed slope. Side slope indicate as small n and slide slope given is 1 by 2, 1 horizontal to 2 vertical. Again bed slope is given to you, that 1 by 1500. Clear? Now we will solve this example. For most economical trapezoidal channel, what are the conditions we derived in our theory? Yes. First, B plus 2ND divided by 2 equals to D under root n square plus 1. And the second condition was M equals to D by 2. Okay. Now, by using first condition, B plus 2ND divided by 2 equals to D into under root n square plus 1. So, here B plus 2 into half into D, because we have n equals to 1 by 2. Divide by 2 equals to d, again n, that is 1 by 2. So d under root 1 by 2 square plus 1. Okay. So by solving this equation you get d equals to 1 upon 236 into d. d equals to 1.236 into d. Okay. Now area of the trapezoidal channel is A equals to B d into B plus nd. We derive this equation in our derivation. A equals to d into B plus nd. We are using this equation directly from the derivation. So now we know the value of area here, which is 40. Now d, that is your unknown. We found B, that is 1.236 into d, plus again n, that is half, into d. So by resolving these values you get d equals to 4.8 meter. D equals to 4.8 meter. Okay. Now what is the equation for B? B, that is 1.236 into d. So by placing the value of d you get B equals to 5.933 meter. So we have the dimension of B and D here, that B 5.93 meter and D, that is 4.8 meter. Okay. Now in this example the second part we have to find out discharge. Discharge, that is your Q. Now for most economical channel, what is equation for M? M equals to d by 2. And by placing value of d here you get M equals to 2.4 meter. 2.4 meter, that is M, and M is your hydraulic mean depth. Now we will use the value of M to find out discharge. The equation for discharge Q equals to C into A under root M I. What is C? Chase's constant. What is A? Area. What is M? Hydraulic mean depth. And what is I? That is bed slope. So by we have all the values here. Capital A, that is 40, C, that is 50, M, that is 2.4, and I, that is 1 divided by 1500. By placing all the values in the equation you get discharge equals to 80 meter cube per second. 80 meter cube per second. Clear? So we found all three values which asked in our example: B, width, D, depth, and discharge, which is your Q. Okay. So done for today, students. Now in next session we will discuss some more theories in this chapter called open channel flow. Clear? And you have to practice some more examples based on rectangular and trapezoidal channel also. Okay. Goodbye.